Okay. Thank you, Himanshu. Dear friends, we are to discuss today an expression for entropy change during an irreversible process. Okay. And if time permits, I would be discussing about what is known as the principle of increase of entropy. So the agenda is twofold. So before that, I would like to ask you a question. Okay. Uh, if if the cycle is irreversible, if the cycle is irreversible, then what is the value of cyclic integral of del q by t? Okay, the question is, if the cycle is irreversible, then what is the value of cyclic integral of del q by t? You can type your answers with your names. Okay, the question is, if the thermodynamic cycle is irreversible, then what is the value of Gunjan? Is it Pranav? Okay, yeah, Pranav correct. Gunjan, it is not correct. If it is irreversible cycle, I am saying Gunjan, if it is an irreversible cycle. Okay, Darshan, you are right. If it is an irreversible cycle, Gunjan, correct your answer. What is the integral of del q? Correct. Is correct. Parikshit Pawar is right answer. Yes, Rushali. Yes. Shirvari, yes. Is if the number of students are able to correct. We have already discussed what is known as the Gaussian inequality, and we had also discussed what is known as Gaussian theorem. Okay. Cyclic integral happens to be less than 0. That is negative. That is, it is negative. That is, it is negative. Okay. So please note that if it is an irreversible cycle, then cyclic integral of del q by t is less than 0. Okay. Let me once again ask you another question. Okay, and don't. I would like the others who have not answered to answer this. What is the value of cyclic integral of t? What is the value of cyclic integral of t if it is a reversible cycle? If it is a reversible cycle. Okay, what is the value of cyclic integral of t if it is a reversible cycle? What is the value of cyclic integral of t if it is a reversible cycle? Value, Vedant. What is the value? Darshan, correct. I want others to answer. What is the value of cyclic integral of t if it is a reversible cycle? Parikshit, no. If it is a reversible cycle, Parikshit. The answer is incorrect, Parikshit. Vedant, you need to correct the value. Vedant Bokre, what is the value I am asking? What is the value of cyclic integral of del q by t if it is a reversible cycle? Yeah, Parikshit, now it is right. Right. Vedant, correct. Correct. The value is correct. Sharvari, it is correct. Pranab is correct. See, this is to be very clear now. This why I am repeating this is because now the definition which I am going to do, okay, that will depend upon this understanding. Sushant, right, Sushant. So you need to be very clear that if it is reversible cycle, then if it is a reversible cycle, then the cyclic integral by t happens to be zero. Happens to be zero. The value of cyclic integral by t is zero if it is a reversible cycle. Okay. What if you see, that cyclic integral of delta by t greater than zero? You see, if you do some calculations and calculate the cyclic integral of delta by t for a cycle, and you find that then what will you conclude? What will you conclude? Anybody? Anybody amongst you? That happens to be greater than zero. Happens to be hello. Yeah. So the question is now, if you find that the cyclic integral of del q by t is greater than zero, then what would be the conclusion? What would be the conclusion? Anybody who knows this answer? It would be that the cycle would be impossible. Okay, it would violate the laws of thermodynamics. So the conclusion would be that if you find that cyclic integral of del q by t happens to be zero, then that cycle is impossible. Okay, that is what is the idea about Clausius inequality. So Clausius inequality, which is of del equal to zero. This is an inequality. Cycle is reversible, whether the cycle is irreversible or the cycle is possible. Okay, so please note that these three conditions are obtained if we get the value of cyclic integral of del q by t for any given thermodynamic cycle. So for any given thermodynamic cycle, you get cyclic integral of del q by t as negative, then you say that that cycle is an irreversible cycle. If you get that cyclic integral of del q by t value is positive, then you say that that thermodynamic cycle is an impossible cycle. We cannot solve that cycle. And if you get that cyclic integral of del q by t happens to be equal to 0, one can say that that cycle is a reversible cycle. Okay. So up to now, we are talking about del q by t, cyclic integral of del q by t. Okay, and using this understanding of Clausius inequality, deriving the expression for entropy change during an irreversible path, irreversible process. Okay, so this is the objective now. Okay. Uh, are you able to see the board where I have some equations, scribbled some expressions? Entropy change during irreversible process. I had written a derivation there. So are you able to see that? Okay, thank you, Gauri. So what you see is I had drawn a cycle here. Okay, so look at this. I use a pressure volume coordinates, right, for drawing a thermodynamic cycle. So one cycle which I had drawn is the following. It is 1 R1 2 R. So mother pen. So one of the cycle which I am considering is 1 R1 R2 1. 1 because the audio connection is lost in. Hello, 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 hello. R1 2 R2 1. Now am I audible now? Yes. Right. So 1 R1 2 R2 1 is one thermodynamic cycle, right? So this thermodynamic cycle which I had drawn 1 R1 2 R2 1, it is a reversible cycle. It is a reversible cycle. Okay. Sorry. Let me write it somewhere else. So this the first cycle. Okay, this one. Okay. This one 1 R1 2 R2 1. This is a reversible cycle. This is a reversible cycle. And you know that if the cycle is reversible, then from the Clausius theorem, what does his theorem say? His theorem says that if the cycle is a reversible cycle, then the cyclic integral of del q by t for that reversible cycle happens to be equal to 0. That value becomes equal to 0. So cyclic integral of del q by t for a reversible cycle happens to be equal to 0 if that cycle is a reversible cycle. Okay, so I have applied the Clausius theorem to this cycle. Which cycle? 1 R1 2 R2 1. Okay, so the cycle which is shown by the solid line, that is 1 R1 2 R2 1, that is a reversible cycle, and I have applied the Clausius theorem to this reversible cycle. So applying the Clausius theorem would be what? It would be cyclic integral of del q by t for this cycle happens to be equal to 0. Now what is the cyclic integral of this cycle, reversible cycle? It is a summation of line integral. It is a summation of line integral del q by t, cycle line integral via r1, and this is the line integral r2. Okay, it's a summation of integral of del q by t via path r1 plus cyclic integral of del q by t via path r2 happens to be equal to 0. Okay, is this step clear? Please say if it is clear. Okay, then you please say yes. Okay, Saurabh, it is clear, right? Pariksha, that is clear. Okay, thank you. Thank you, Ritesh. So, again, I will be repeating that I had considered a reversible cycle in the diagram, which you see that reversible cycle, and that reversible cycle is 1 R1 2 R2 1. What I had done is that for that reversible cycle, I have applied the Clausius theorem, and I have got, let me call this as equation 1. Let me call this as equation 1. Okay, integral of del q by t via path r1 plus integral of del q by t via path r2 has to be equal to 0 for this reversible cycle. Okay, now what I do is that in the second part of the proof, I now consider a irreversible cycle. Okay, so that irreversible cycle, I am choosing another pen. Let me choose a blue pen. Okay, that irreversible cycle is, let us say, 1 R1, 1 R1, 2 IR2, IR2, and 1. Okay, so this reversible cycle is this cycle is an irreversible cycle. This cycle is an irreversible cycle which I am now considering. Okay, this is the irreversible cycle. So this irreversible cycle has two processes, of which one process is the reversible cycle, that is 1 R12. This is a one process which is a reversible process, and the other process which I had shown by dotted line, is the irreversible process, that is 2 to 1 via IR2. 2 to 1 via IR2 is an irreversible process, and this cycle then becomes an irreversible cycle. This cycle becomes an irreversible cycle. So applying the Clausius inequality, which is written over here, that if it is an irreversible cycle, look at this, then the Clausius inequality says that the value of cyclic integral of del q by t is negative. Cyclic integral of del q by t, if it is a irreversible cycle, not a reversible cycle. Okay, if it is an irreversible cycle, cyclic integral of del q by t happens to be negative if it is a irreversible cycle. So what I am doing now is I am applying this condition to this cycle, irreversible cycle. Okay, so then what is that? Cyclic integral of del q by t for an irreversible cycle is summation of line integral 1 to 2 del q by t via path r1 plus summation of line integral 2 to 1 via path ir2 del q by t, which is equal to, now this is important, this is less than 0, that is this is the negative value, that is this is a negative value. Okay, please note this is negative value. Okay, I hope this is understood. If this is understood, please say yes in your questions column whether this is understood for irreversible cycle. Okay, Nikhil Pardesi, thank you. Shanavari, thank you. Vedant, thank you. Right, so please note, Aniket, thank you. So please note that if it is a, yes, Himanshu, if it is the irreversible cycle, then cyclic integral of del q by t is negative, and that is what I had written. Okay, now let me call this as equation 2. Let me call this as equation 2. Okay, so now it is a matter of simple understanding of mathematics. Now you have already studied the inequality and equality in algebra. Okay, so what we will be doing is that now we will be having a closer look at equations 1 and 2. What we will be doing is that we will be having a closer look at equation 1 and 2. In a way, we will be comparing equation 1 with 2. Okay, and if you look at equation 1 and 2, then it becomes but obvious. It becomes but obvious that line integral, and this line integral is between the states 2 and 1. Okay, this line integral is between the states 2 and 1. Okay, so this line integral of del q by t, this line integral of del q by t, okay, for a reversible path, this line integral of del q by t for a reversible path has to be greater than the line integral of del q by t along the irreversible path. Okay, if you reflect on equations 1 and 2, look at this, that in this equations 1 and 2, these terms, that is this term and this term, are same. Okay, these two terms are identical. In fact, we had chosen a cycle in a way that they remain identical. Okay, so these two terms, they are identical, right? Now these two terms are identical, right? So what is to be left for comparison is the second term of equation 1 and second term of equation 2. And you see that this is 0 and this is negative. Okay, equation 1, it is 0 and equation 2 is negative. So if this is so, then obviously this value along this value of line integral del q by t along the irreversible path, this value of integral del q by t along the irreversible path, that is the second term along which is a along irreversible path, has to be less than the corresponding value along a reversible path, has to be less than the corresponding. So if you compare this term, that is irreversible path term, with the reversible part term, then the obvious conclusion is what I had written. Okay, the obvious conclusion is what I had written. So let me write down this. Let me just highlight this using the green box. Okay, whatever is the color. Okay, it is a green box. Okay, so you see that this 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 box, if you look at this, then both this are line integrals between 2 and 1. The difference is one is along the reversible path, other is along irreversible path. So what you find is that if you take a line integral between the end states along a reversible path, then that value of del q by t happens to be greater than the one which you obtain along the irreversible path. Okay, so this is just, it follows from the mathematics that this value, this term is greater than the term which is along the irreversible path. Okay, now by definition of entropy change, what did we say? That entropy change is, because entropy is a property, so the entropy change is given by the integral which is performed along the reversible path. Okay, so the integral which is performed along the reversible path has to reflect the entropy change, so this term, that is integral of del q by t from 2 to 1 along the reversible path, this term, that is integral of del q by t from 2 to 1 along the reversible path, what is this term? This term is ds, that is change in entropy. This term is change in entropy. So this becomes, now this equation turns to integral of 2 to 1 ds, integral of 2 to 1 ds, okay, happens to be greater than integral of del q by t from 2 to 1 along the irreversible path, and if this 2 and 1, if they happen to be very close, then one can say that ds is greater than del q by t if this is a irreversible path. So what we have obtained is an expression for entropy change during a irreversible process. Okay, expression for entropy change during an irreversible process. So what do we conclude? That the entropy change, okay, for a irreversible process, the entropy change for a irreversible process happens to be greater than del q by t, happens to be greater than del q by t. And this is a very important finding. Okay, this is a very important finding. So let me once again repeat what I have done. I have derived an expression for entropy change during an irreversible process. Okay, irreversible process. So in the derivation, what I had done was that I had chosen one reversible cycle, one R1, 2, R2, 1, and I had chosen another cycle which is the irreversible cycle, which is 1 R1, 2, IR2, 1. Then what I did was I had applied the Clausius inequality, right, which is the Clausius theorem for reversible cycle and which is the inequality for a irreversible cycle. Okay, so applying the Clausius theorem to the reversible cycle, I had written this cyclic integral as equal to 0, and for an irreversible cycle I had written this cyclic integral as negative, that is less than 0. And then I had elaborated, I had rather written the cyclic integral in the form of line integrals, summation of line integrals. So when I had written this as a summation of line integrals, so I had got this expression 1 and expression 2, right? In the expression 1 and 2, my first terms are identical. In my equations 1 and 2, my first terms are identical. So it is a matter of comparing the second terms. It is a matter of comparing the second terms. And by a careful look at the second terms, I conclude that the line integral of del q by t, okay, between the paths, between the states 2 and 1 for a reversible path happens to be greater than the cyclic integral del q, sorry, not cyclic integral, line integral del q by t between the path 2 and 1 if it is an irreversible path. Okay, now from the definition of entropy change, I had replaced the reversible path line integral with ds, reversible path line integral with line integral of ds. New expression which I get if I call this as equation 3, that equation 3 is integral of ds 2 to 1 happens to be greater than integral of del q by t, okay, which is del q by t performed along the irreversible path. Okay, and if that 2 and 1 they happen to be closer, then I can find rewrite this expression in a elemental form, that is ds for a irreversible path happens to be greater than del q by t. Okay, happens to be greater than del q by t, and we already know that if it is a path is reversible, then this ds is equal to del q by t. So again you are getting an inequality here. For any process. So what is that inequality? That if the ds for a process happens to be equal to del q by t, if the ds happens to be equal to del q by t, then you say that it is a reversible path. Because this, if you consider irreversible path between the same two states, then that value of ds okay. So this is an expression for the entropy change. This is an expression for entropy change, okay, during an irreversible process, Mind well, now we are not talking about cycles, we are talking about now a process. We are not talking about a cycle, we are talking about a process, right? We also know what we know from the definition of entropy change which we had derived, that entropy change during a reversible process. Mind well, now I am talking about a process, not a cycle. During a reversible process, I am not talking about cycle now, please note, I am repeating this again. I am talking about a process. So what is the expression for reversible process? That expression is ds okay, is equal to del q by t, okay. So look at this. I am trying to help you get insights about these expressions. Okay, what if you look at these two expressions? Right? you would say that this ds irreversible is equal to ds reversible plus, or let me say this, uh, del q by t, reversible plus some value x, which has to be positive. If I want to replace the inequality sign, from the equation 1, okay, so can I write that as this, purely mathematical point of view? Okay, can I write this as uh, this new equation? Can I rewrite the equation 1 as equation 3? Yes or no? Tell me if it is yes, tell me if it is no. Can I rewrite this as equation 3? Can I rewrite the equation 1 as equation 3? Yes or no? Zai, yes. Okay, thank you, Zai. Samir, yes. Akansha is saying yes. Mohan is saying yes. Okay. Please note that the value of x has to be greater than 0. If I have to write it, then the value of x has to be greater than 0. Okay. So what does it tell you? Okay, what does it tell you? It tells you that this is basically entropy change. This is basically entropy change during a process. During a process. During a process. Okay. So why is the entropy changing during a process? The entropy is changing during the process because of two things. Entropy is changing during the process because of two things. One is because of the heat transfer. One is because of the heat transfer. Okay. And second is what is this x? What is this x? Why is the entropy changing? One is because of the heat transfer. And what is this x? What does the x tell you? Why is that entropy changing? Can somebody figure it out? Why is that entropy changing? One is because of the heat transfer. And what is the second reason? What is the second reason which is captured by the value of x? What is the second reason for the entropy to change during a process? What is the second reason for the entropy to change during the process? No, it is not the heat loss Xi. It is not the heat loss Xi. Anybody who can figure it out? You can look at the expressions 1, 2, and 3, and you can figure it out. Okay. Just reflect on the equations 1, 2, and 3, and somebody I'm sure would be figuring it out. Why is that the entropy is changing for during the process 3? Okay, when you are writing the process 3, or what that x tells you? What that x tells you? What does that x tells you? What does that x tell you? Nobody knows? All right. Let me tell you. This x is, if you look at the equations 1 and 2, this x is going to tell you about the irreversibilities. It is basically the irreversibility which it is capturing. So it is basically quantifying the irreversibility during the process. Are you getting it? Are you getting this? So the entropy change during a process is because of two factors. One is because of the heat transfer that the entropy changes. Okay. And second is because of irreversibilities, which is because we are talking about an irreversible process. It is because of irreversibilities that the entropy is changed. So entropy change expression which are derived during an irreversible process, it tells you two things. One is the entropy is changing during an irreversible process because of heat transfer, and second is the entropy is changing because there is an irreversibility associated during the process. Okay, so can you tell me, looking at the equation 2, can you tell me why is the entropy changing in the equation 2? Why is the entropy changing during the equation 2? Okay, look at the equation 2 and tell me that it is a reversible process. It is a reversible process, right? Equation 2 is the expression for reversible process, and it is an expression for entropy change. My question is, why is the entropy changing? Why is the entropy changing during a reversible process? Can the entropy change during the reversible process? Yes or no? Can the entropy change during the reversible process? Yes or no? And if it is changing, why is Parikshit is saying it cannot change? If it is changing, why is it changing? Look at the equation 2 and think of it. Look at the equation 2 and think about it without initial to final stage. No, but why is it changing? That is okay, entropy changing, but why is it changing during a reversible process? The entropy, if you look at the equation 2, which is the equation for entropy change during a reversible process, we can see that the entropy is changing because of heat transfer. The entropy is changing because of heat transfer. And if you remember our discussion which we had using the microscopic thermodynamics concepts, we had seen that whenever there is a heat transfer, there is an increase in molecular disorder. If there is a heat transfer to the system, there would be an increase in the molecular disorder, and hence it would lead to entropy change. So the entropy change during a reversible process can be understood by looking at the heat transfer expression. Okay, so can the entropy decrease during a reversible process? Can the entropy decrease during an reversible process? Can the entropy decrease during the reversible process? Yes or no? If the process is reversible, can the entropy decrease? Anybody? If the process is a all on this, thanks for joining. So I'm leaving this discussion unconcluded. Okay, I'm leaving this discussion. It's an open question. You think on this. I had given you a question that whether the entropy decreases during a reversible process. If if no, why not? Okay, and this kind of stuff. Okay, so you are required to think on the entropy change which happens during a process, both the reversible process and irreversible process. Think about it and come back with the answer during the tomorrow's lecture. Okay, thanks for joining. Thanks for being online. Have a good day. I'm ending this webinar.